Solving simultaneous equations using substitution. So we talked previously about simultaneous equations, and it means finding the x value and the y value that fit both equations. Graphically, that represents the point where those two lines cross. We can use a graphical method to solve simultaneous equations, but it's inaccurate and it's unnecessarily cumbersome. So we want to look at, there are two possible algebraic methods that we might use when dealing with simultaneous equations. And the first one we're going to look at is the method of substitution. In both algebraic methods, the aim is to create, you've got two equations with two unknowns in them, and the aim is to take those two equations and somehow manipulate them to create one equation with only one unknown. So you can then solve and find your solution. So in this case, we're going to use the method of substitution. And generally you would use substitution when x or y is the subject of one of the equations or both of the equations. So in this first example here, y is the subject in both of the equations I'm dealing with. So substitution is an ideal method to use here. So the idea of substitution is that you take one of the equations and substitute it into the other equation. So the idea here is that the first equation, for example, is telling me what y is equal to. So in the second equation, I can replace y with that. So, or vice versa in this particular case, because both equations have y as the subject. You could also think about this as the first equation is telling me that y is equal to 4 minus 3x, and the second equation tells me that y is equal to 5 minus 2x. So the logical conclusion, therefore, is that 4 minus 3x must be equal to 5 minus 2x. When solving simultaneous equations, it's a good idea to really keep track of what you're doing. So I always will number the two equations that I'm starting with and be clear in my mind about what it is I'm doing. This becomes particularly important with the second method, elimination, but still a good habit to get into when solving simultaneous equations all the time. So I've got two equations, equation 1 and equation 2. In this particular example, I'm going to choose to substitute equation 1 into equation 2. So I'm going to take the fact that equation 1 tells me that y equals 4 minus 3x, and I'm going to substitute that in place of y in the second equation. So I'm going to have the equation 4 minus 3x is equal to 5 minus 2x. And in doing that, I've now created this one equation which only has x in it. So I should be able to solve this equation for x. So I'm going to add 3x to both sides. And I'm going to subtract 5 from both sides. So x is equal to negative 1. Then we need to find the simultaneous solution has two parts to it, the x coordinate and the y coordinate, the x value and the y value. So we know that the x value in this case is negative 1. We wish to find the corresponding y value, and you can use either of your original equations to do that. So we can substitute x is equal to negative 1 into, and you can pick which one you'd prefer to use. I'll go with equation 1. So y is therefore equal to 4 minus 3 times negative 1. So that's 4 plus 3, so y is equal to 7. So therefore the simultaneous solution is x equals negative 1 and y equals 7. Graphically, these two lines would cross at the point negative 1, 7. Let's have a look at a second example. So again, remembering the key to substitution as being the optimum method is having x or y as the subject in one, or at least one of the equations. So in this pair of equations here, x is the subject in equation 2. So that's going to be the equation that I substitute into the other equation. So I'm going to be substituting equation 2 into equation 1. You'll also note that sometimes it's fairly easy to do a quick rearrangement to make x or y the subject, so it would be very easy to rearrange equation 1 to make y the subject and then do the substitution, but it's not necessary in this case given that I already have x as the subject in the second equation. If neither equation had x or y as the subject, you could rearrange to make x or y the subject and then use substitution. And in fact, substitution is the method you would use even when you're dealing with nonlinear equations, quadratic equations or cubic equations. You should always be able to make x or y the subject of one and make a substitution. Having said that, in some equations, making x or y the subject creates quite difficult algebra to deal with. Okay, so in this case we're going to be substituting equation 2 into equation 1, and we've chosen to do that because equation 2 tells us what x is equal to. That's equal to x. So I'm going to take that, I'm going to replace x in the other equation with that. So we're going to have y minus 2 times 2y plus 5. Always use brackets when making a substitution, particularly if it's necessary in this case because of the 2 times x. So we need to do 2 times all of 2y plus 5. But it's a good habit to always write the substituted expression in brackets and then deal with what's going on. So now we have one equation with only y in it. So we should be able to solve this equation for y. So we're going to expand out the bracket first. So y minus 4y minus 10. Watch that negative there. So negative 2 multiplied by 2y and negative 2 multiplied by 5. So y minus 4y is negative 3y. I'm going to add 10 to both sides at the same time. So y is going to be equal to negative 9 divided by negative 3, so y equals 3. And then we need to substitute y equals 3 back into one of our original equations. Always easier to go back into the one that you substituted in, because in this we're trying to find x now, and in the second equation x is the subject. So substituting back into this equation won't require any solving, it'll just require some evaluation. So x is equal to 2 times y, which in this case is 3, plus 5. So 6 plus 5, so 11. So therefore my solution here is x equals 11, y equals 3. So graphically, these two lines would cross at the point 11, 3.